So we started looking at data visualization and interpretation some times back. So we continue from where we stopped. Okay, so we have looked at how we can make line plots. So today we'll be looking at 2D plots and some other things. So one of the 2D plots that you can make is the bar chart. Okay, so it could be one numeric part and one categorical part, or the two sides could be numeric in nature. So we see those two examples as we move on. So if you want to make a bar chart, the function to use is bar. The regular bar chart that you are used to, the function to use is bar. You open the parentheses and supply the values. Okay, so let's say for example we have the test scores for some students. So the students, they are 5, so it's from 1 to 5. So that's what's going to be on our x-axis, and the height of the bar chart is going to show what each student scored. So that's going to be on the y-axis. So if you want to put that as a bar chart, what we just simply need to do is to say bar, then pass in our x data set followed by the y data set. They will be separated by a comma. So if you want to add label, it's the typical way we have been adding label before now, and if you need to put title, it's still the same procedure. So let's try this. The data we have here, we want to represent it as a bar chart. Just give me a moment, let me refactor my screen. Okay. So I'm getting my X data set. And I want it to be bar, represented as a bar. So if I run this script now, let me see what happens. Anyone without comps here? So he's still busy getting the outcome. You can see the status here. So that is what it looks like. So if you need to put the title, you can put the title, but we already treated that before now, so we don't need to do that again at this point. Okay. So now this is a case that the vertical and horizontal axis are numeric. So what if the horizontal axis is actually categorical, something like we have on the board? Maybe you want to group some things like that are character or string in nature, something like fruits, something like maybe cars and all of that. You want to group them. So how do you do that? So it's just if it's bar chart, it's still bar command, but what you just need to do now is to convert those strings into a category. so that Matlab can be able to get the bar chart for you. So let's work on what we have on the board. We have fruits. Someone is selling fruits, and he wants to compare the sales for different categories of fruit. So the fruit is listed, as you have seen. Then the sales for each of the fruit is also listed in that order. So to create for such a situation, what you need to do, since it's not numeric, the x-axis is not numeric, you use curly braces instead of a regular square bracket that you are used to. You use curly braces, and each of the items you put in a single quote, and you separate the items by a comma. Okay, but the one that is the typical numeric data, it's the way we used to handle them that we are going to handle them. So let's create a list of fruits. We have apples, bananas, cherries, dates, elderberries. We have that. Okay, so now that we've created that, the next thing is, what is the sale for each item, category of item? So we are presenting that also to Matlab. So now, the intermediate step is now that we have to convert that fruit into a category. So how do we do that? You might store it in something tentative. In the note, I did not store the conversion into a tentative variable. So you might choose to skip that, but the major thing is that you have to convert it into a category. So let's create a variable called fruits underscore carts. Okay, so what are we doing? You want to call the function categorical. So there is a function called categorical that helps us to convert that array of strings into a category. So categorical, then normally you open the parentheses. So what are you passing into categorical? Fruits, right? Because that is your intention. Okay, semicolon. So now that we have that, what we now be passing into bar is going to be fruit underscore cati, comma, sales. That's what we are going to be constructing as a bar chart. So okay, so let's see what the outcome looks like. Sorry. Yeah. Okay, let me run it and let's see if we have what we need. Okay, so we have the sales of our fruits represented as a bar chart using that route. So you can add the title, you can add the labels. It's okay. Here are some examples, some exercises for you to try your hands on. So apart from the regular bar chart, you can also have the horizontal bar charts. So it's still the same procedure, but with a tweak. Instead of using bar as a function to get the graphics, you now use bar H. So every other thing is the same thing. So if the two axes are numerical, you just use bar H and you pass in the data set. If one is a category and the other one is numeric, then you have to convert the one that is a string into a category by using the function categorical before you pass it into the bar H function. So let's just do an example. So the same data set we worked with initially, that's what we are going to also work with now. Okay, so let's say we have X data set as seen on the board, and this is the Y data set. So we can get them and call bar H instead of bar. So bar H. So you know your X comes before your Y data set, right? So X comma Y. So let us run it and see the outcome. So that is what it looks like. You can do the same thing for the second example we had the other time. Okay, in addition to this, you can customize the color. You can customize the color of your bar chart. You see, by default it's giving you blue as the face color, right? And the edge color is what? Black by default, but you can choose what you want it to be. So let's say we want, instead of blue for the face color, let's say we want red. Okay, so we can pass in red as the third argument. We had X and Y as the first and second argument, right? So the third argument can be the color. So what did we say about color? So we had some letters that represent colors, and usually when you want to pass in the color, it's going to be in quotation. So let's say we want it to be red now. So you put red in quotation, okay, as the third argument. So let me run it again and see what happens to the figure that I have there. So now I have decided what the face color is going to be. So let's say I don't want the edge color to be black as default. I can also specify that. So because I'll be specifying two things, the face color and the edge color, then I will have to do it a little bit differently. So I will tell you that this is the color of the face color. So we say face color is red, okay, followed by the edge color again is red, but you might choose another color. Let me choose another color for now so that you can actually see the difference very well. So instead of this R, I'll replace it with the names and value. So face color is still red, edge color is, let me change it to cyan. So, and let's see what happens. Oh, I copied something extra, right? Yeah, it should work now. So what's it saying? Okay, there is a missing quotation mark somewhere. Okay. Okay, you see that the edge color has changed to the color I specified. So let me make it red so that everything balances well, is harmonious. Okay, you have seen the difference from what we started with. So aside from bar charts, which is a 2D graph, you can also do your histogram. Okay, normally you will use histogram when you want to study the changes that is happening over a period. So you have a period of data set that have been grouped, right? So you want to see what's the pattern like for different periods. So that's when you use your histogram. So to use histogram, basically you can just call HIST function. Okay, and in some instances you can call histogram instead of hist. You can call histogram. So let's start with calling hist. So when you call hist, you pass in the data set. Then if you want to maybe customize the color, then you can go for histogram instead of saying hist. Okay, so let's see some examples. So they say that this is scores for some students. And you are supposed to plot a histogram for the test scores. Okay, so you have that. You could ask Matlab to just plot histogram for you without telling me that this is the number of groups that you should divide the data to. So if you don't specify the number of groups to divide the data to, it's just going to determine that for you. So let's look at an example of that. So the first exercise is that you are just going to call hist on the data set. Okay, and you are not going to specify the number of groups you are dividing the data into. But the second case, you are going to specify that you want to divide the data into 5 groups. So what it's going to be doing is that it's going to divide the data into groups, and the vertical axis is going to be the frequency for that group of interval. I think you can still remember your histogram to an extent. So this is the scores that we are given. So it has been arranged as a vector. This is a row vector, right? Okay, so that's our data set as an array. So we want to construct histogram. We don't care what number of groups we have, we just want to see the histogram. So we just say hist of the score. So this time around, what you are passing it is the scores that you have. So this is the scores. So histogram. Let's start with hist first. Okay. So let me run it and see what it has for us. So this is what it has for us. Since you didn't specify a particular number of division, so it has decided on your behalf, and that is what is showing to you. So let's go to the case that you have specified the number of divisions you are looking at. So if you want to say divide this data into 5, like the question said, what you are going to do is that you are first of all going to pass the data. In this case, you have named this scores, then followed by comma and the number of data sets, the number of groups you intend to divide the data set into. In this case, it is 5. Okay, so let's try that again. So instead of just saying hist scores, we are saying hist scores, comma 5. So let's see what happens differently. So you see that you have 5 bars, which is number of groups that you have asked it to divide it into. So what did it do here? So I believed what it did was, okay, let's look at the data set. The least value here is 65, right? Am I right? And the highest value is what? 95. So remove 65 from 95. That's what? That's 30. So you want 5 groups. So it assumes that the interval between the groups is constant, equal. So how do we determine the interval? So that 30 divided by 5 will give you 6. So if you observe that the values that he has mapped out for you, 68, 74, 80, 86, 92, they are 6, 6. The difference between each one is 6. The consecutive values, right? The difference is 6. So what happens? What it's going to do is that 68 is at the center of the first bar. So that means 3 to the left, 3 to the right. Okay? The same thing with 74, 3 to this side, 3 to the other side. So for the last one, remove 3 from 92 and add 3 to 92. That will give you your 95, which is the highest value. And for 68, remove 3 from 68. That will give you 65. So that is how it works. So anything falling in between those values is what the frequency is, what it has given to you. So when you are working on your own, that explanation that I give to you, look at the data set and you will comprehend how it got those frequencies. But what I've shown you here is that you can actually specify, okay, this is the number of intervals or the number of groups that I actually want for my histogram, instead of just leaving it to Matlab to decide. Another thing you can do is, you can, instead of saying 5 bins, you can actually specify the bin edge. You know, it has, when you told it I want 5 groups, it determined the bin edge for you. It says 68, 74, 80, 86, 92. But you can decide on that okay, this is the bin edge that I want. Yes, I want 5 intervals, but I am looking at having this bin edge, which is 60, 70, 80, 90, 100. So it's going to construct the histogram for you based on that, and the frequency of each of the group is going to change based on the bin edge that you have chosen. Okay. So if you are deciding the bin edge by yourself, you pass in the data set that you want to graph first. So this time around, instead of passing in the number of bins, which was 5, now you are going to pass in the bin edge, which is going to be 60, 70, 80, 90, 100. Okay, and that's it. So, but if you want to maybe customize the color also, if you want to do that, then you can move ahead to do that also. But to be able to customize the color, you have to change it to histogram instead of east that we have been using. So let's start with east first. Then after that, we go to histogram so that we can change the color as we deem fit. So we need to provide the bin edge also. We need to define that first before we can run the histogram function. Okay, so now I can run it and see what happens. So it has utilized the bin edge that I've provided. So because nothing is between 96 to 100, that's why you are seeing 0 there. Okay, because that 90 is going to be 90 minus 5 and 90 plus 5. Okay, so that means that last bar that you have seen has captured even the highest data that we have there. So anything from 95 to 105, there is nothing there. So that's why it's 0. Okay, so now that we've seen that, so we want to change the face color to another thing. So we say histogram. So we have that. So let's say we want the edge color to move away from what it is now. To another color. So let's say green. So now it's edge color. Edge capital. So instead of black outline, we should expect something like green. So that is what makes it work. Okay, so you see how to change the face color and the edge color if you need to do so. So we may have reason to construct histogram that is a normalized histogram. What does it mean? Okay, so instead of just grouping the data set and looking for the pattern changes in period, now you want to see what's the probability of this value showing up in the data set. That's what it's about. Okay, so what you just need to do is still the histogram command. You pass in the data set that you want to normalize. Then the first thing that comes up after the data set is normalization, then probability. So that means, so let's see what happens here. When I say probability, I think the highest is 1, right? The probability of a thing happening, of an occurrence, does not exceed 1. Okay. So here is our data set. So now what we want to do is to normalize the data set. We want to see, okay, each of these members, what is the probability of getting them. So this is the command that does that for us. So let's see what we have if we run this command. Let's see. Okay. So every other thing has the same. Let me run this on my window command instead. Busy. Okay, yeah. So we can see it clearer. So because every other member, apart from 85, occurred only one time and we have maybe 15 members, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, we have 15 members, so 1 over 15 should give you that value that is around this area, and the one that has twice the others is appearing at this level. So you have normalized it. You are seeing, you are trying to study what's the probability of me having this item in my list. Okay. Another thing you can do with histogram is that, okay, I have two separate data sets, let's say test 1, test 2. So I want to compare the pattern or what's happening to those two data. You can also use histogram. So in this case, we have the first data set, we have called it test 1 underscore scores, and the values are seen there. And the second data set is, we have called it test 2 underscore scores, and we have that. So you can use histogram command to compare them. So like we used to do, the first thing is that you present your data set. Okay, so these are our data sets. Okay, so since we are plotting two graphs on the same axis, you will need hold on, right, as a command. Perhaps after you have plotted the first one, you put hold on, then you now plot the second one. Or as you have seen on the board, you can hold on first before you present what you want to plot. It's still going to work the same way. Then a good practice is that once you are done plotting, once you are done stacking it on the axis that you want, the next thing is that you hold off. Then here, since we are having two data sets that I want to plot on the same axis, so this is where the knowledge of you being able to decide what the color of the histogram is, this is where it comes handy. Okay, so you might just decide to change the face color alone and leave the outline as black. So you can say, okay, maybe the first one is going to be blue and the other one is going to be red, as we have here for the comparison. So we have presented the data set. So let's plot the first one as an histogram. Histogram is good to use here because eventually we'll be changing the face color. For you to be able to change anything color, you have to be using histogram as your function. So we are plotting test 1 scores first, and we want the face color of the histogram to be blue. Let me run that first and see what it looks like. So this is what it's looking like. So I think this time around we have 11 data points. So that is what it looks like. And there is an item occurring twice. Okay, it's still 85 occurring twice. So that's why you have this like this, is occurring twice. Every other item is occurring 1 1. Okay. Okay, so that being said, we want to stack the other one on it. So hold on. So we are saying this second data set, let it be in red. So let us run it and have the results. Okay. Okay, so we have red, we have brick colors. This is the outcome. We have red and brick color. So the brick color is where the values in the first data set and the second data set coincide. So they have, where they have the same value, that's where the color change from what we asked it to be. So for this item 85 occurred only once in dataset 2. Okay, so that's why it's here. And for the first dataset, it occurred twice, 1, 2. So that's why you have blue here. So saying that, okay, dataset 85, okay, in dataset 1, 85 occurred twice, but in dataset 1, it only occurred once. Then every other item is 1, 1. And where the color differs from what we asked it to be is actually where the two data sets have something in common. So those are the things you can use your histogram to do. So if you need to, since you have two data sets here, if you need to put a legend, this is a very good place to put legend. You know how to pass in legend using the function legend, and you pass in the names of those data sets in the same order that you have plotted them. So if you need to do that, please feel free to do that. So let's move on to 3D plots. So the 3D plot that we are going to be looking at is 3-dimensional line plots, surface plots, and mesh plots. Okay, so for the 3-dimensional line plots, the function to use is plot 3. When it was 2-dimensional, we just use plot. But in this case, if it's going to be 3-dimensional line plots, the command to use is plot 3. For surface graphs, the function to use is surf, S-U-R-F, as you have seen on the board. Then if it's mesh that you want to get, the function to use is M-E-S-H. Okay? So there is this example here that says X equals to cos t, Y equals to sin t, and Z equals to t. So you are supposed to plot that as a 3D diagram for t varying from 0 to pi to 10 pi, for t varying from 0 to 10 pi. So for us to have something smooth, so that's why we put that interval in between that creates that small interval that makes the diagram look smooth. So the interval is going to be pi over 50. So it's just as straightforward like that. So what you are doing is, since you are getting 3-dimensional, you are looking at getting 3-dimensional line plot, you use plot 3 and you supply what you need to supply. So let's see how it works. X, Y, Z is what you are going to supply in that order. Okay. So what do we do? The first thing is to create our variable. They've told us the range of values for our t. It's going to range from 0 to 10 pi, and we want it very smooth, so we say okay, in between them, in between each point is 0 over pi. So we use the shorthand method of creating data set that we have looked in when we were doing arrays. Okay, so the first thing is create your t and let it be equal to what we have just said. So when you create your t, you get your x from your t based on the function that you are given for x. The same thing with y, get your y, and I've been told that z is just equals to t. So you do that. Then you call plot 3. You pass in your x, y, and z as the argument, each separated by a comma. If you need to put the labels and the title, it's still the same way we have been doing. So let me run it. Okay, so that's a 3D diagram, line plot. If I want more than that, let's say I want the grid lines to show, I can put the grid on. Grid on. So I'm saying grid on. Let me run it again and see if something happens differently. So I hope you can see that the grid is now showing. Let me try and expand this. So because of that grid on command, it's now showing the grid lines. So we move on to surface plots. So just like we passed in X, Y, and Z into plot 3 when we wanted line plots, so the same thing is what we are going to pass into surf as a function. But before we pass X, Y, and Z, okay, we need to mesh the grid of X and Y. Why is that so? For you to use surf, what you are passing into surf should be a matrix. Okay? So for it to be a matrix, you have to use mesh grid on the data set of X and Y first. So once you are done with that, then you can now get your Z and you pass everything inside your surf. Okay, so that's important. Making it a matrix before you say surf X, Y, Z is important. So how do I make it a matrix? So I'll use mesh grid function first. So here's the question. So the question says that I should plot a surface for the function z equals to sine s square plus y square, where x and y range from -2 to 2. So we are starting from -2, we are ending at 2. So to make it very smooth, we have said that over and over, we can put an interval between that will make it look smooth. So in this case, so the interval is 0.1 instead of the default 1 that Matlab would have used for you. So now you are using 0.1 as the interval between -2 and 2. Okay, so let's create the matrix x, y, sort of. Okay. Mesh grid. As a function. So what's going into that function? Y, x, y. So x is moving from -2 to 2, as well as y moving from -2 to 2. So this is the function. So you open the parentheses. We are using scripts, so that's why it's important to put the semicolon. So what I'll put in inside that function, the range of values for x followed by that of y. So that's it. So now we can now get our z from x and y. So the question says z is equal to sine x squared plus y squared. Okay, so that's why we have dots correct sine 2, dots correct sine 2. So that dot is just saying, well, this is scalar. So now you can now use solve. Solve x, y, z, semicolon. So let's run it. Let's see if you have an output. So that is what it's looking like. Okay. So in case you are doing research and you need to produce a surface plot, that's how you go about it. So we can add a color bar also, just to indicate what height it is. So each color is an indicator of what the height is. So how do we add color bar? We just say color bar. So you can now interpret it very well that okay, this is like this height, this is like that height. Okay. So we move on to mesh. So mesh is similar to surface plot. The only thing is that the in between the mesh is not filled up. Nothing fills that place up. Okay, that's the major difference between the mesh and the surface plot. So the route is still the same. You need to get your matrix first, your matrix of your x and y. Then you get your z from those matrices. Once you get it, now instead of calling surface, since it's mesh that you want to get, you call mesh. So that's the difference. So I'm going to be replacing surf with mesh because that's what is different. That's the difference between them. The route is the same. Okay, so let's see how it looks. So that's it. So you see that in between the mesh is not filled up like what we had the other time. So you can combine multiple 3D graphs together. Okay, you can combine it together. What you just need to do is you use hold on. When you plot the first one, you can hold on, then you plot the other one. So let's say we have this data set now. Okay, so x and y, they are both varying from -5 to 5, and perhaps you have decided that okay, the interval between the points is 0.5 instead of 1. So that's what we have on the board. So you use mesh grid to create the matrix. So once you get that, so let's say you have two z, one is z1, one is z2, and the function is different. So let's say z1 is equal to sine of the square root of s squared plus y squared, and the other one is cos of square root of s squared plus y squared. Okay, so maybe you want to use one for mesh plot and you want to use the other one for surface plot. Okay, so let's imagine that. So this is our data set, just to show us that we can combine 3D graphs on the same axis. So that generates the matrix we are going to need. Then from there we can grade our z as a function of x, y, and z. So for the surface plot, we are using Z1. So X, Y, Z1. And for the mesh plot, we are using Z2. So let's plot the surface plot first and hold on. So what we are saying is, for the surface plot, we have X, Y, and we are using Z1. But we are not done. We want to hold on and make a plot of mesh using Z2 data. Okay. Okay. So we said best practice is that you hold off once you are done plotting, right? So let's see what happens. So that's it. Yeah. So this one is the surface plot and this is the mesh on the same axis. So with that, we've covered what I want to show you on the topic data visualization and interpretation. So you can apply it in any way that is relevant to you.